We know that 5 times 5 is 25, and similarly that the square root of 25 is 5. But what if we're working with variables? Well, suppose we have x times x. That's x squared. The square root of x squared is simply x. Remember, when we take the square root of a number, we're saying what number times itself 2 times gives me that number that's in the radicand. In our first example, what number squared gives me 25? Well, that's 5 squared. In our second example down here, what times itself twice, or what squared, gives me x squared? Well, x times x. Therefore, the square root of x squared is simply x. When we're working with variables and square roots, we simplify as we always do. In the first example, we have the square root of 125n. We can break that up. Square root of 25 and the square root of 5. We also have the square root of n. Square root of 25 is 5, and we're left with a 5 and an n on the inside. Example 2 is the square root of 216v. Please pause the video here and try this example. 216 breaks down to 36 and 6, and we also have the square root of v. That gives us 6 square roots of 6v. But what if our variable has an exponent that's larger than 1? In example 3, we have 512k squared. Once again, we break it up. 512 is 256 and 2. We also have k squared. We know that the square root of 256 is 16. We also know that the square root of k squared is simply k. What squared gives me k squared? Well, k. So the 16k is on the outside. Left on the inside, in the radicand, is the square root of 2. Sometimes folks think of this in the following way. How many groups of 2 k's do I have? If I have k squared, that means there's 2 k's on the inside. One group of 2, which means the one group of 2 comes on the outside simply as k. Example 4 has something a little different. We have the square root of 512, m to the third. Once again, we'll break that down. 512 is 256 and 2. M to the third, well, let me break it down into a perfect square and a not perfect square. M squared is a perfect square. It's a power of 2. Square root of m is our leftover piece. We break down the radicals. 256 is 16. The m squared becomes m. That leaves me with 16m square roots of 2m. If we think about it in groups of 2, there were 3 m's in the radicand. That's one group of 2, that's the m on the outside, with one left over, that's the m on the inside. What if we have 2 separate variables? How would we deal with that? Well, we'll deal with it the same way we did the last one. Please pause the video here and give this example a try. 147 is 49 and 3. M to the third, we have m squared and m. N to the third, we have n squared and n. That gives me 7 m n on the outside, 3 m n on the inside of the radical. Once again, if we think of our variables in groups of 2, we have one group of 2 with one left over. The one group goes on the outside, the leftovers on the inside. The n is the same thing. One group of 2, that group of 2 goes on the outside as n, and we have one left over on the inside, that's the n in the radical. Example 6, we have a power of 4. Once again, we'll break this up. The 200 is 102. We have m to the fourth, that's the square root of m squared, and the square root of m squared, with a single n left on the inside. That means I have 10m times m, 10m squared, with a square root of 2n on the inside. Now let's once again think of groups of 2. If I have m to the fourth, that means I have 4 m's on the inside. I have two groups of 2. Therefore, m squared, the exponent is how many groups of 2 came out, and none left over. The next two examples are for you to try. Please pause the video here, then come on back. Let's see how you do. Square root of 36x squared, y to the third, becomes 6xy, square root of y. Example 8, 64 and 6 gives me the 384. I have x to the fourth, which is two groups of 2, and y to the third, which is one group of 2, with a single one left over. Number 9 is multiplication. We can apply all the rules of multiplication and division when working with radicals. Multiply the insides, multiply the outsides. 15 times 10 is 150. N squared times n to the third is n to the fifth. I simply added the exponents. Now I can go ahead and break down my radicals in order to simplify. In the end, I end up with 5n squared, square roots of 6n. Notice the n squared on the outside. I had n to the fifth, which gives me two groups of 2, with one left over. Number 10 is for you to try. Please pause the video here, then let's take a look and see how you did. And by multiplying the outsides, the 4 and the 1, and the insides, the 18a squared times the 3a squared. Now I can simplify my radical. 54 is 9 and 6, and I have a to the fourth, which is square root of a squared, and square root of a squared. 4 times 3 is 12, a squared, square roots of 6. Once again, notice in my radical I had a to the fourth, that's two groups of 2, and so I have a to the second, that's on the outside. Number 11 and number 12 are also for you to try. Please pause the video here, then come on back. Let's see how you do. Multiply the outsides, multiply the insides, and then we go ahead and we simplify the radical. On example 12, we did the same thing. Multiply the outsides, multiply the insides, and then we go ahead and simplify. Let's take a look at one last example. This is a fun one. Well, I take a look at it, and I can begin by reducing the 15xy and the 10xy to the third. That gives me a square root of 3 on the top and 3 square roots of 2y squared in the denominator. I can't leave a square root in the denominator. I have to rationalize. And so I multiply both the numerator and the denominator by the square root of 2y squared. Now I go ahead, I multiply the numerators and I multiply the denominators. Remember, when we do this process of rationalizing the denominator, the goal is to end up with a perfect square down there, and that's exactly what happens. 4y to the fourth, which comes on out, is 2y squared. In the end, I have the square root of 6 over 6y. So what do you need to know? Well, when you're dealing with square roots that contain exponents, remember that the variables come out in groups of 2. The square root of x squared is simply x. The square root of x to the fourth is x squared. There were two groups of 2. Then you just simplify your square roots as you normally do. This is everything you need to know about working with radicals containing exponents.